Hello, welcome to another section of Math. I hope you guys are doing well. Well, in this video, I'm going to show you how you can use substitution together with other differentiation rules or formulas, other differentiation formulas to differentiate this problem, to solve this problem. Actually, we are differentiating the whole thing. We are differentiating the whole of this. Okay, so here I'm going to show you how you can use the substitution together with other differentiation formulas to solve this problem. So what do you think? Will it be easy or difficult? Oh, looking at the problem, it's like there are lots of them involved. 1, 2, 3, and every one of them is not that easy, with the exception of this one. We know how to solve the derivative of this. That one is easy, but as compared to this, multiply by that, and also this multiply by that. Even this one alone is not all that easy to solve or to differentiate. But well, you don't worry. You're going to find out how, when you get problems of this nature, when they are in this form, how you can go by using any other approach. How I'm going to solve the problem does not it's not because of the approach I'm using, but I'm just going to um, show you maybe how you can solve this problem without without having any difficulty, only if you know what you are doing, or what you are going to do. If you know what you are going to do, somebody may choose to, the expert, maybe they will write answer for this one directly, they also do this one directly, and blah blah blah, put the answers together and they are good to go. But I'm just going to let everything be in step by step. We will start with this one, and when we are done getting answer for this, we move on to this and that of this, and when we are done, we just put our answers back. Okay, so I think that would be the easier way for us, which will help us, get some understanding from it. Okay, so guys, without wasting much time, let's get into the video. First, let's write our solution. Okay, so what are we differentiating? That is this one. So let's bring it down here. All right. Now the other time, remember I said when it's in this form, you will find it difficult. Maybe not difficult differentiate, but difficult making the substitution what approach, or difficult applying the substitution what approach here. But when it's of this form, maybe whatever formula that you are going to use, you can just code the formula and then do whatever you want to do. Maybe even if it's of this form, you can still solve it using what the formulas. Okay, But here, remember the other time I said, if you want to apply the substitution approach, first you have to what? Let it be in form of equation. You have to let a variable be equal to the whole of this. Make sure when you are choosing your variable, make sure the variable involved in the question is not included, or it does not choose any variable that is in what the question. So we are going to pick any variable aside what x, any variable at all. Okay. By differentiation, normally what do you see? Y over x, something like that. So we are going to let y be equal to this one. So we are going to put y be equal to the whole of this. Now let's write our equation. Okay, y is equal to minus x raised to the power minus 1 into bracket ln x natural log of x all squared minus 2 x raised to the power minus 1 multiplied by natural log of x minus 2 times x raised to the power minus 1. Okay, remember I said only if you know what you are going to do, how I'm going to solve this problem is what you need to maybe um, consider. Like I said, if you know what you are going to do, you know how to differentiate this, how to solve this, and how to also, do other algebra that will be involving. That is why I'm saying, if you know what you are going to do, the only thing you need is to maybe how to split these ones before you differentiate. Okay, so if you're able to split it or separate them, maybe the work the differentiation will be what easy for you. Okay, when we choose to differentiate the whole of all this simultaneously, well, somebody can do that, but some of us will find it difficult what getting the understanding. So here we are going to separate them, or we are going to differentiate them in bits. You will start with this one, and when we are done, we will come to this one, and when we are done, we move on to this. Now the answers that we get for each of them, we just put them together, and whatever that we have to do, then we just do it and see what answer we are going to get at the end of the day. Okay, so now that we know what we are going to do, so let's split them. Now I'm going to call this this one. I said we are starting with this one. So I'm going to call minus x raised to the power minus 1 multiplied by into bracket natural log of x all squared. I'm going to call that one a, and also I'll call this one b, and I'll call this one c. Why am I doing it? I'm doing it so that we can easily work on each of them. Somebody can also choose to separate it directly from here. We say the derivative of this one as 1, and then we'll just write another something like this for this also, and also for this one. If you use that one also, that one also is also good. That one also is also correct. And if you don't do it that way and you want to do it the way I'm going to separate this, that one also is also good. Anyhow you choose. The motive of doing it that way is to just help work on the motive of doing that is to help you solve the problem easily without encountering any difficulty. Okay, because when we are differentiating the whole of this at the same time, you think it will that be easy? You have to omit some formulas, and just you have to omit some calculation, just write answer for this one straightforward. Or for some of us, will find it difficult knowing how the answer come by. Okay, so I think the best way to solve this one in order to generate understanding is to do it in bits. Maybe we solve this one alone, we know, so that we can know how, when you differentiate this, what you are going to get. I mean, the steps involved in getting what the answer to this, and also this one, and also this one, so that even the weakest among us will be able to know at least, oh, here we did this to get this, here we did this to get this, here we did that to get this. Okay, so that is why I'm separating them or splitting them. Okay, so like I said, I'll call this one A, this one B, and then this one C. But mind you, because we will put our answers back together again, I'm omitting the operation sign. I'm not taking them along, so I'm just going to take x raised to the power minus 1 multiplied by, into bracket, natural log of x all squared. And when I'm taking this one too, I'll not bring this one. When I'm taking this one too, this operation sign, this minus sign, I'll not bring. I'll only just pick this one. I'll only just pick this and also pick this one. Okay, so let's continue. So we are going to pick this one. So differentiation of a. So let's differentiate a. I said when you are choosing the variable, make sure you don't choose what is in the question. Okay, so here we are going to let m be equal to x raised to the power minus 1 multiplied by, into bracket, natural log of x all squared, natural log of x all squared. Now let's form the equation. So m is equal to, okay, here we are going to do another substitution. We are going to do a substitution before we differentiate. We are going to let u be equal to this one. Okay, so u is equal to natural log of x. Now we here, you could see we are moving from x word into u word, and we know what is replacing what, natural log of x, but there is still x here. So let's find out what is going to replace it. Okay, now if you leave that x there, how many variables will we involve? I guess if we put u here, it will be u, x, and then m, 3 variables, so at least it should be 2. At least it should be 2. Okay, it should be 2, so that the differentiation will work out for us easily. Okay, let's let's not make it 3. So let's find what is going to replace x. So let's take e of both sides. If you take e of both sides, you're going to get e to the power u is equal to natural log of, is equal to e to the power natural log of x, which the e and the natural log will cancel out and to be left with x. So we are going to get x is equal to e to the power u. Now let's differentiate this one. When you differentiate this, we are going to get e to the power u du, and when you differentiate this, we all know that is what, dx. Okay, so let's find du. We shouldn't find ds, but rather we should find du. Okay, so let's divide both sides by e to the power u. When you do that, this is what you are going to get, 1 over e to the power u divided by, multiplied by dx. We did it this way because in the original equation, when we differentiate, you are going to get what, this, because of the substitution. And later on, going back to the else word, we just replace this one with this. Okay, so let's write our original equation. M is equal to u. Okay, good. U replace natural log of x, which was all squared, so that is here. So natural log of x all squared is being replaced by what, u. So here we are going to get u squared, and remember it was x raised to the power minus 1, and we know what was going to replace x. The other part, we had x is equal to e to the power what, u, but remember x was raised to the power minus 1, So x raised to the power minus 1 can be written as x into bracket raised to the power minus what? 1. Okay, so when you replace x with e to the power u and you multiply it by the minus 1, it is what you are going to get. So our original equation is now u squared multiplied by e to the power u. Remember I said we are using substitution and then other differentiation formulas to solve this problem. So here I'm going to solve this one using the product rule, but I'm not going to write it down. That will make the workings very lengthy. So I'm not going to write it down, but I'll just explain them. And even if I don't write it down, or if I don't let you see it here, still when you get problems of this nature and you are to use the product rule, you will know how to do it. It's very simple. The product rule is very simple. Okay, so to differentiate this one using the product rule, you all know the formula for product rule. Remember, at the end of the day you just add. So it's something d something plus something d something. Okay, good. So here u squared multiplied by e to the power u, e to the power minus u. First, we are going to remember addition and multiplication is what? Commutative. So if you either choose to maintain this one first and then differentiate this, or you maintain this and then differentiate this, anyhow you are going to get your answer. Remember, addition and multiplication are what? Commutative. So first, just maintain one of them. Just maintain one of them. So let's see if we maintain this one. When we maintain this one, that is e to the power minus u, we are going to maintain it. Then we differentiate this. When we differentiate this, we are going to get 2u. So the first part will give us 2u multiplied by e raised to the power minus u. 2u multiplied by e raised to the power minus u. And the next part, the first one, we maintain this. Okay, so here we are going to maintain u squared. We are going to maintain u squared. So when we maintain u squared and then we differentiate this one, we are going to get, now to differentiate this, you just multiply. When you differentiate this, you are going to get u squared multiplied by minus e raised to the power minus e raised to the power minus u. Okay, and when you multiply, you're going to get minus u squared e raised to the power minus u. You can also choose to do it this way. First, you maintain this one and then you differentiate this. Now when you do it that way, if you differentiate this one first, this is what you are going to get. The derivative of this one is minus e multiplied by minus e raised to the power minus u. Minus e raised to the power minus u. Then you multiply it by what? U squared. That is the first part. So the answer that you get for this one is minus u squared multiplied by e raised to the power minus u. And then the next one, you just maintain this one and then you differentiate this. So when you maintain this one and differentiate this, you're going to get 2u multiplied by e raised to the power minus u. So at the end of the day, the answer that you're going to get is either minus u squared multiplied by e raised to the power minus u plus 2u e raised to the power minus u, or 2u e raised to the power minus u plus minus u squared e raised to the power minus u. So anyhow you do it, you're going to get your answer. So dm is equal to, like I said, anyhow you do it, I'm just going to get the same answer at the end of the day. Okay, so first, remember that first we maintain this one and then we differentiated this. We maintained this and we differentiated this, and this is what we had. Remember we had that. We had that because this one is what? Negative. So when you differentiate it, that minus sign will affect the base one also. So minus e raised to the power minus u multiplied by u squared will give us what? This one. Okay. And now because we maintain this one first, the next one we are going to maintain this and then we differentiate this. And remember the one also we had 2u multiplied by e raised to the power what? Minus u. And this one you can rearrange it. Or remember I said either this way or this one first and then you subtract this one. They are all the same. They are all the same. They are all just going to give you the same answers. Okay. So dm is equal to, when we differentiate it, this is what we are going to get at the end of the day. Now let's put our s back. We know what is replacing the u, and we know what will be also replacing what um, u and then e raised to the power minus u. Okay, so let's put them back. So we know that du is equal to, that you can see from here, that du is equal to this one, and then we know that x is equal to u is equal to natural log of what? X. And we also know that e raised to the power u, which is maybe this one, is equal to what? X is equal to what? X. It's just a matter of rewriting e raised to the power minus u, and that one can be written as e raised to the power u bracket close multiplied by raised to the power minus 1, e raised into bracket e raised to the power u bracket close raised to the power minus 1. And by that we just replace our e raised to the power u with what? X, and then we multiply by the minus power 1, and then we will get x raised to the power minus 1. So let's replace them. Okay, here that is what we placed the u here. But here it was e to the power what? U. And we know what is what e to the power u is equal to. E to the power u is equal to what? X. So here that is the x here. And remember I said e to the power minus u can be written as into bracket e to the power u raised to the power minus 1. And when you do that, that is this one showing what I said, and the same thing is applied here. And we know what is replacing what? U, that is what? Ln x. So when we come here, you see that here it was u squared. We know that u is what? Ln x. So when we do that, this is what we are going to get. That is into bracket natural log of x all squared. Remember I said it can be what? Rewrite. We can just write another form. This minus plus this minus 2 plus 1 is the same as 1 minus 2 is the same thing as that. Okay, so this one is the same thing here. When we do it like this, is a little bit confusing. So when you write it this form, everybody know this form rather than this. Yeah, a lot of people are familiar with this form rather than what this. When you do it this way, they get a little bit confused. But the moment you write this, you say, oh, yeah. So that's why I did it this way. So now let's continue. Let's find dm over dx. So to find dm over dx, we are going to multiply through by 1 over dx, 1 over dx, 1 over dx. Good. You remember dm is equal to this one. dm is equal to this, that is this, and then multiply by that. And we want to find dm over ds. We want to find dm over ds. So to do that, we are just going to multiply this one through by 1 over dx. 1 over ds. When you do that, the ds which is here can be what? Eliminated. So to do that, we are just going to multiply through by 1 over ds. So here when you multiply this one by 1 over ds, it will give us dm over dx, and it's equal to, now when you come to this side, this and this will cancel out, and to be left with what? 1 over x. So dm over ds is equal to this one multiplied by 1 over x. 1 over x. Good. Here it was this form, and here I change it to this form directly. Yeah, s raised to the power minus 1, using the negative index law of indices, it can be written as a raised to the power minus 1 can be written as 1 over a. 1 over a. So this one can be written as 2ln x over x. 2ln x over x, all because of the indices law, the negative index law of what? Indices. That is 1 over a can be written as a raised to the power minus 1. That is, if you want to change it from here to this part, you apply that one. Or if you want to change it from here to this part, you apply a raised to the power minus 1 is equal to 1 over a. 1 over a. 1 over a. So when we change it from this form, when we change it from here, that is what we are going to get, and it's all because of the negative index law of what? Indices. This s raised to the power minus 1 here can be written as 1 over x. 1 over x, and we multiply that numerator, which is 1, by just 2ln x, and that is what we are going to get. Okay, so dm over dx is equal to 2ln x divided by x minus natural log of, into bracket, natural log of x all squared divided by x, multiplied by 1 over x. 1 over x. Okay, so let's continue. Now here you can see that the denominators are the same. So what will you do? Well, you just write one of the denominators, and then we subtract the numerators, and whatever we get, you just multiply it by what? The 1 over x. So dm over dx is equal to, like I said, it's a like fraction because the denominators are the same. So we are just going to subtract this, and that is going to give us 2ln x minus natural log of x all squared divided by x, multiplied by 1 over x. So when we open this bracket, dm over dx is equal to 2 natural log of x minus this one divided by the product of this and that will give us x squared. Okay, so the answer to the derivative of x raised to the power minus 1 multiplied by, into bracket, natural log of x all squared is this one. So this is what we have gotten for the a part. This is the answer to what? A. So now that we have gotten answer to a, let's move on to b. Let's move on to b. Differentiation of b. Okay, so let's write b. As usual, we always set what we are going to differentiate be equal to something, so that our substitution will work out for us. So here p is equal to 2 multiplied by x raised to the power minus 1 ln x. Now let's write our equation. P is equal to 2 multiplied by x raised to the power minus 1 times ln x. As usual, let's make substitution. like I said, you can still apply the rule here without, you can still apply the rule here without any substitution. But because I've written it in this form, I'm applying what? The substitution. Okay, so we are going to let a variable replace what? This L and X, this L and X. We are going to find something to replace what? This L and X, so that our differentiation will be what? Easier. Okay, so we are going to let V be equal to natural log of X, V be equal to natural log of X. Now, we know what is going to replace natural log of X, so let's find what will be replacing what? X. So let's take e of both sides, and when you do that, you're going to get x raised to the power ev. S is equal to e to the power what? Ev. E to the power, e to the power v, e to the power v. Now let's differentiate. When you differentiate this, you're going to get e to the power v dv is equal to dx. Now let's find dv. Let's find dv. And we can do that by dividing both sides by e raised to the power v. And when we do that, dv will be equal to 1 over e raised to the power v multiplied by dx. Okay, dv is equal to this one. Okay, we know what will be replacing dv when you differentiate the original one. So let's move on to the original one. P is equal to 2 multiplied by e raised to the power minus v times what? V. You know v is replacing natural log of x, and e raised to the power minus v is replacing x raised to the power minus 1, and you already know why. So let's carry on. Okay, here to differentiate this one, the same product rule is going to be applied. The same product rule is going to be applied. The same product rule is going to be what? Applied. So first we are going to maintain one, differentiate the other, and then we maintain the other and differentiate what? The next one. Okay, so let's maintain this one, and then let's differentiate this. If you maintain this, 2 times e raised to the power minus v, and then we differentiate what? V. When you differentiate v, you are going to get what? 1. And 1 multiplied by this will give us what? 2 multiplied by e raised to the power minus 1. And then we maintain this. So the next one, we are going to maintain this one, and then we differentiate e raised to the power minus 1. You know, the 2 here is attached to this, so don't bother yourself. If you consider the whole of 2 multiplied by e raised to the power minus v, that one too is another thing on its own. So to be on the safer side, just maintain the 2, don't touch it. Whatever you get, just multiply it together with whatever you get. Okay, so let's differentiate e raised to the power minus v. If you differentiate e raised to the power minus v, it's like what we get for the other one. This one is going to give us minus e raised to the power minus v, and then we multiply by what? V, and then the 2, and that will give us minus 2v e raised to the power minus what? V. Okay, so now let's put it down. dp is equal to 2 multiplied by e raised to the power minus v minus 2v e raised to the power minus v dv. And you know how we got this, and you also know why we got this one also. Let's go back to the else world. So remember, we let v be equal to something. So if you are going back to the else word, let's replace what was substituted for v. Okay, and also we know that this one, the v is equal to what? This one. So here we are going to put this one there, and wherever we see v, we are going to put what was substituted for, and also the same thing for what? E to the power minus v. The p is equal to 2 over e to the power v minus 2v over e to the power v multiplied by the v. Well, here we have changed it to the fraction form directly. We have changed it to the fraction form directly. That is, now when we rewrite this one, or if you convert this one to fraction, because of the negative index law of indices, it's going to be 1 over e raised to the power v. 1 over e raised to the power v. So when we convert it, this is what we are going to get. This is what we are also going to get. Okay, remember I said here that we know what is replacing, what is going to replace v, and also what is going to replace e to the power minus v, and also what is going to be replaced with the v. Okay, so either you replace it from here directly, or you will do it this form and then you replace it anyhow. You're just going to get the same answer. So don't just get confused because we didn't replace it here directly before doing this part. They are all going to give you the same answer. Anyhow you do it, you're just going to get the same answers. Okay, good. As I said, we know what is replacing what? V, that is L and X, and what is replacing the V, that is what? This one, or what? The whole of what? This. And also e raised to the power v, we know what is replacing that, that is what? X. That is X. That is what? X. So let's replace them. Good. Here you are not seeing any x raised to the power anything because we have, write it in the fraction form. The x raised to the power minus 1, we have already changed it. That is why we are seeing what? X. And it's because of 2 divided by e raised to the power v. It was e raised to the power minus v. Yeah, e raised to the power minus v. And when we write that one is bracket open e raised to the power v bracket close raised to the power minus 1, and that will give you your x. And when you multiply, you get x raised to the power minus 1. But we first convert that one to fraction before this part. Okay, that's why we have just gotten this one directly. Okay, so here this 1 over x minus 2 ln x divided by x multiplied by dx over x. Now we need to find dp over ds. So to do that, this one and this one, remember, it's a like fraction, so we can give it one denominator and then we subtract this one, after which we multiply what? This one through, or we multiply it by 1 over what? X. But before we do that, ds is here, so we should find something, we should do something to eliminate what? Dx. We should do something to eliminate what? Dx. And what will we do? Well, we can multiply both sides by 1 over dx, multiply this one by 1 over dx, and also multiply this one by 1 over dx. And when we do that, you can see that the multiplication on this side will take away what? Dx. Okay, we'll take away what? Dx. Good. You said, remember I said when you multiply through by 1 over dx, you could see that the multiplication on this right hand side will take away dx because you get 1 over dx, and that dx will cancel out with this dx, okay, and it will be left with 1 over hot x. So dp over ds is now equal to, and remember I also said that this one can be written this one can be written it in this form, all because of the denominators are the same, so it's a like fraction, so we just write one denominator and then we subtract the numerators, okay. So that is why we had this, okay. So now that we know dp over dx, let's write the answer for the product of this. Let's write the answer for the product of this. So dp over ds will be now equal to this one multiplied by 1 over x, this one multiplied by 1 over x, and that will give us this one divided by x squared. Okay, so this is the answer for the b part. This is the answer for the b part. So dp over dx is now equal to 2 minus 2 ln x over x squared. So quickly let's move on to c. Let's move on to c. Though doing it this way has helped us know every step in getting answer for each of them. Every step in getting answer for each of them. If you hadn't do it this way, then pen down our answer directly, we could have made some steps and some that we could have made some steps which is reflecting how each answer is coming by. So let's put c down. First we are going to remember always set it to something. So here we're going to let z be equal to 2 multiplied by x raised to the power minus 1. This one is easy, very easy to differentiate. Even this one, if you don't write in the form of equation, or if we don't use the product rule, we can still differentiate this one using what? The power rule. Yeah, the power rule, because the power for this one is minus 1, and with differentiation you multiply the power by the base and you decrease the power by 1. Yeah, and that one can work here, that one can work here. So here I don't think we will be using the product rule or something. So let's write our equation. All right, let's differentiate. I said this one is simple, so let's differentiate. Now the z over the x is equal to minus 2 over x squared, and it's so because now when you differentiate this one, let's put our focus on the x raised to the power minus 1. The power is minus 1. It's not positive 1 whereby you will get s raised to the power 0 after differentiation. No, the power is what? Minus 1. The power is minus 1. So to differentiate it, we multiply the power by the base, and already the base is being multiplied by 2. So it will be 2 times the minus 1 times the base, and that will give us minus 2x. Minus 2x. And when we consider the power is already minus 1, and then we are going to decrease it by minus 1 again. So when we decrease it by minus 1, it's going to be minus 1, and that is going to give us minus 2, minus 2, minus 2. So when we differentiate this, we're going to get 2x raised to the power minus 2. And remember, the negative index law of indices, we can write that one in this form. So applying that negative index law of indices, that is how come we got this. So when you apply that, we're going to get minus 2 over x squared, minus 2 over x squared. So the z over ds is equal to this. Now we've gotten answers for each of them. So what are we going to do? Let's put our answers back, and then we do some algebra, then we find out what we are going to get at the end of the day as our final answer. So let's put our answers back. So add the derivative of a, b, and c together. Add the derivative of a, b, c, a, b, and c together. After differentiating what we had for each of the letters here, for c, what did we get? We had what? This one. That is what I mean by add the derivative of a, b, and c together. You can also write add maybe dz over dx, the variables that you use in solving the differentiation. Maybe here we use dz over dx, and the other part we had dp over dx. You can write it in that form, like add dz over dx, and then dp over dx, and then the what over the blah blah. Okay, you can do it that way. That one too is also accepted, but here I wrote it the derivative of this. What I mean by this is the answers we got for each of them. The answers we had for a, b, and then c, we are going to put them together. Okay, so to add all our answers together means we have done finding dy over ds. Remember, the original question was equated to y, so to was equated to y to differentiate. And after differentiating that particular question, you're going to get dy over ds. So if you have gotten answers to all of them and we are adding, it's a matter of, it shows that we have differentiated that particular thing, that whole thing. So what shows that we have differentiated, and now we are, or what shows that we have differentiated is dy over dx is telling us that we have differentiated that particular question. Okay, so dy over dx is now equal to minus, remember it was, all of them were negative. That is why, remember, initially I said I'm omitting the negative sign written, or the negative sign involved in them. Okay, so dy over dx is equal to, and this is the reason why I decided to not include the negative sign attached to each of them, because at the end of the day I know I'm going to put them back, and if I attach them and then use it in my workings, it might confuse some of us. That is why I omitted that one. Okay, so dy over dx is equal to minus a minus b minus c. Okay, now we can factor out our minus 1, and dy over dx will give us minus 1 into bracket a plus b plus c. When you do it that way, when you do it this way, it looks, very cool, right? And when we do it this way, many people will, will like it rather than this part. Minus minus might confuse some of us, but when it's plus plus plus, all we know is adding, and at the end of the day we just multiply by minus 1 and we are good to go. Okay, so now let's put our answers that we had for each of them here. Okay, a, this is the answer we had for a. B, this is the answer we had for B. All of them were positive. We had positive answers. But for C, we had negative answer. That is why here is what? Minus 2 over x squared. minus 2 over x squared. Now here you could see that all of them are having the same denominator, which is what, x squared. So we're just going to write 1 and then we add or subtract the numerators. So let's do that. Good. Now here, remember I said after you are done with differentiation, probably there might be some algebra that you have to do. Answer to particular derivative question may not come directly. Some of them, yeah, probably may not come directly. After you are done differentiating, no matter the number of differentiation you did, maybe there will still be some algebra that you have to do. I mean, there will be some algebra that you have to do in order to get your final answer to that particular um, question. The fact that it was being separated by a lot of opposing signs does not mean getting answer for each of them is the end. No, there are some questions when you differentiate, when you integrate them, you are going to get, different answers. You're just going to get maybe something plus, something minus, something blah 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 blah. So when you differentiate, it's up to you to do some algebra or maybe compute them in order to get that particular answer that you are looking for. If we leave them in this way, with respect to what is here, we are correct, but because we are looking for particular answer, we can't end it here. We have to compute, or we have to do some algebra. Doing some algebra simply means, we have to, find out if we can add some, subtract some, divide some, something like that. Okay, so here we are going to find out if we can add some, subtract some, or eliminate some, something like that. Computation. You multiply, you add some, you take away some, something like that. Okay, so here that is what we are going to do here. Now, when we give it one denominator and then we add or subtract the numerator, that is what we are going to get. That is 2 multiplied by natural log of x minus into bracket natural log of x all squared plus 2 minus 2 natural log of x minus 2. Now here you could see that this minus 2 here and this 2 here are the same, so it will cancel out. This one is positive and this one is negative, so this and this will cancel out. And also you could see that this one 2l and x is negative. 2l and x and then 2l and x are also the same, so this minus 2l and x and then this 2l and x is also going to cancel out. This one is negative and this one is positive, so this will cancel out with this one. Okay, and also this cancel out with what, this one, and it will be left with minus into bracket natural log of x all squared divided by what, x squared. Okay, remember it's in a bracket. Okay, so we will definitely open the bracket to know what we are going to get at the end of the day. So assuming if you have not do the algebra as we did here, how will I go to know that at the end of the day when I add some or subtract some, I'm going to get a particular answer, or I'm going to get a particular, to be left with what, maybe a particular variable or a particular what, to be left with what, a particular variable or maybe a particular what answer. So anytime you differentiate something and there were about the question involved was being separated by plus or minus, and maybe was about 2 or 3 things that you were working on. After that, it could be that particular when you the answer to that derivative of that you are working on when integrated gave that question you are working on. So the moment you are done with the differentiation, you have to do some algebra. You have to find out if you can add some, subtract some, eliminate some. Doing that will help you know what you are going to get at the end of the day. Okay, and if you are able to do that, you get to know that, oh, okay, probably it will when you do that, probably you get some of them being what remain, and whatever you get at the end of the day after that computation was what the answer to that derivative. Like this one here, you see this and this is being cancelled out, this and that also is being cancelled out, but here we cannot do anything again, and what is being remain here, that is minus natural log of x all squared divided by what x squared, and that is our answer. That means that one was integrated to get the whole of what we are just differentiating. Okay, so if you don't do that algebra, you will not get to know the final answer at the end of the day. All these answers are correct, but because we are adding or subtracting some, you need to do that particular algebra. You need to do that computation aspect. Okay, so now let's continue. So dy over dx is now equal to, remember I said when you do that, it will left with what? A particular answer. Okay, you see, a lot of them has what been eliminated and has just left with what? This one. So make sure after differentiation you do that. You check if you can add or subtract some. Okay, so let's get our final answer, and it's simple. There's nothing here that we can do again. The only thing is to what? Open the bracket. Okay, so if you open the bracket, this multiplied by this will give us positive answer, that is into bracket natural log of x all squared divided by what? X squared. So dy over dx is equal to, dy over dx is now equal to natural log of x all squared divided by x squared. See, was not that easy. If we hadn't done the computation aspect, there could have been a lot of answers involved, and with that from that lot of the answers that we had is one particular answer which when integrated will give that whole question we are just differentiating. Wasn't that easy? So derivative of what we just differentiated is what? Bracket open, natural log of x, bracket close, raised to the power 2 divided by what? X squared. X squared. You remember in one of my videos, I integrated this problem. I intentionally decided not to say it or inform you. I inform you of it in the introduction aspect. I intentionally decided to do it that way. So you remember in one of my videos I integrated this problem, and what we just differentiated is what I had as my final answer. So I decided to differentiate to find out if I will get that question back. And at the end of the day, after this lengthy workings, or after this these talented workings, were able to come out with the original question which we integrated. That's cool, right? Well, that's it. So let's conclude it. So therefore, the derivative of Therefore, the derivative of this was the answer that I had to the integral of this one. You don't worry, I'll leave a link to that video in my description section below. Okay, so if you haven't watched this, if you haven't watched that video, maybe you just go and click on that one and then you enjoy yourself with it. After integrating this one, that is what I had. This is what I had. And remember I said if you integrate if you integrate something and you differentiate the answer you have to something, you have to get your something back. That is what I integrated, and now I'm differentiating what the answer, and I'm done, and I have gotten what that something, which is what this one back. And this confirms that differentiation integration is like they move together. When you solve this one and you differentiate this one, what you integrated, you should get it back from differentiation. Okay. Oh, I hope some of you might be having a whole lot of questions to ask, but you could see that, the workings we the workings was quite very simple. We didn't encounter any difficulty, all because of the splitting that we did. Because we separated them, you could see that we didn't encounter any difficulty, and everything was obvious, everything was simple, clear, and easy to understand. There wasn't any some complex calculations, and maybe we didn't get any confused or something like that. Everything was simple, and it's all because of the um, splitting aspect or the separation that we did. When we are to differentiate problems of this nature, you can do it the way as I have done mine. Okay, when you do it this form, it helps you to easily deal with each of them. I'm not saying you cannot easily deal with each of them directly from here. Those who are expert, but some of us who want to, get more knowledge about it will prefer, doing it in what bit. Okay. Well, what do you think? Uh, if you want me to know what you think, probably you do it in the comment section below. Okay, so you let me know what you think, or maybe if you have any question, make sure you drop in the comment section below, and I'll do my possible best to answer you. Okay, all right, that's it, guys. I know some of you might be though you know what I mean now. All right, that's it, guys. If you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching.